my friends, this is Sonu Kumar. I welcome you in this Nptel online courses. Today I have discussed the assignment 8 of soil mechanics. So let us start the assignment. This is the assignment 8 and the first question of the assignment is at the depth of 5.5 meter below the ground surface at a site, the van shear test gave a torque value of 6145 Newton centimeter at failure. The van was 12 centimeter high and 6 meter in diameter. The shear strength of a soil will be what? A zoom shear occurs at the top and the bottom of the van. So let's see the solution for this question. This is the solution. D is equal to pi cu d square h by 2 plus dq by 6. Put all the value and we get cu. That means 7.766 Newton per centimeter square. That is converted into kilonewton per meter square. That means 77.66 kilonewton per meter square. That means option B will be the correct option. You can go with the option number B. This is the option. Option B is the correct. Now move to the question number 2. This is the question number 2. Here, Teraji consolidation theory is applicable to one-dimensional consolidation test. That means option C will be the correct for the load increment ratio of nearly 1. That means option C will be the correct option. You can go with the option number C. Now move to the question number 3. This is the question number 3. Which of the following statements regarding coefficient of consolidation is correct? This is the formula Cv is equal to K by Mv into gamma W. That means according to option Cv is directly proportional to K. That means option A will be the correct option. You can go with the option number A. Now move to the question number 4. This is the question number 4. In this question, we have to find the coefficient of compressibility. That means AV we have to find. So let's see the solution for this question. This is the solution for question number 4. AV is equal to E0 minus E by sigma dash minus sigma 0 dash. That means put the value of sigma 0 and put the value in this equation, and we got 0.01. That means option C. This is the option C. That means 0.01 is the correct option. You can go with this. Now move to the question number 5. This is the question number 5. In this question, over consolidated ratio of value 4. The normally consolidated soil is 1. That means option B will be the correct option. You can go with the option number B. Now move to the question number 6. This is the question number 6. In this question, we have to find the initial void ratio. So let's see the solution for this question. This is the solution. MV is equal to AV by 1 plus E0. That means AV is equal to E0 minus E by sigma dash minus sigma 0 dash into this 1 plus E0. That means MV is given in the question. From there we can find E0. That means initial void ratio 1.16. That means option D. This is the option D, 1.16. You can go with this. This is the correct answer. Now move to the question number 7. This is the question number 7. In this question, we have to find the total consolidated settlement of a clay. Strata is 70 centimeter. Then we have to find the thickness of the strata in meter. So let's see the solution for this question. This is the overall solution. The formula is used here. Delta H by H is equal to E0 minus E by 1 plus E0. Delta H is given in the question and we have to find the H. Put all the value in this equation and got H is equal to 4.18 4.18 meter. 4.18 meter. That means option C will be the correct answer. This is the option C. You can go with the option number C. Now move to the question number 8. This is the question number 8. In this question, we have to compute the probable primary concentration settlement of the structure. So let's see the solution. This is the correct solution. Here, delta H is equal to mv into dp into H. This formula can be used. So first of all, we find mv, that means ab by 1 plus e0, that means e0 minus e by sigma dash minus sigma 0 dash into 1 by 1 plus e0. Put all the value in this equation and got mv is equal to 5.92 into 10 to the power minus 4. And then put mv in this equation, and dp is given in the question 140, and h height is given in the question, and finally we got the answer 24.9 centimeter. That means option D will be the correct option. You can go with option number D. This is the correct option, option D. Now move to the question number 9. This is the question number 9. In this question, we have to calculate the consolidation settlement of 4 millimeter thick clay layer, which is overlain by a deep layer of intact cell. If the construction of a new footing increase the average overburden pressure by 65%, and the initial overburden pressure is 220 kilopascal, and given the coefficient of volume change is equal to dash 0.0024 meter square per kilonewton. So let's see the solution for this question. This is the overall solution. The consideration del H is equal to mv into dp into H. mv is given in the question and dp is also given in the question, and H is given, and for here dp is given in the question 65% of the overall pressure, that means 220. Then we got dp is equal to 143, and put and the value in the equation, and we got delta H is equal to, that means concentration is equal to 137 centimeter. That means option B will be the correct option. You can go with option number B. This is the correct option, option B, 137. Now move to the question number 10. This is the question number 10. In this question, we have to find the primary concentration settlement of the building. So let's see the solution. This is the overall solution. In this question, we have to use the formula delta H, that means concentration, primary consolidation delta H is equal to Cc into H by 1 plus E0 log sigma 0 dash plus del sigma dash by sigma 0 dash. Here Cc value is calculated by this formula, and all the data are given in the question. Put all the data in the question, this formula, and got finally the answer is 130.4 millimeter. That means option D will be the correct option with option D. If you will face any problem, you can ask me in the comment section. I will try to reply as well as soon. That's all. Thank you.